For Module 12, we're going to take a look at data center reliability. And every data center needs to have a level of reliability in order to maintain the uptime periods that we look for. So keep in mind that every piece or every component, every system in the data center has a useful life, which means this is how long the manufacturer expects this equipment to run correctly. But at some points in time, we can have components or pieces in there that will break down. So we're going to define data center reliability by the probability that the system is going to perform at a specific point in time or over a specific period of time. We can calculate what the probability of non-failure of a system is over a period of time, assuming normal operating conditions, and we can correlate it with a system or product and its operational quality over a period of time. All right, the benefits of reliability are going to increase our high availability levels, which will then have an impact on our cost management. And it's going to impact cost because it can minimize failures, minimize the time that it takes us to fix things, maybe reduce the amount of replacement parts that we have on hand, and reliability can improve safety. So reliability is going to be important to the data center to help us measure our ability to consistently provide service to their customers. Okay, reliability is different than the life cycle phases of a product. It's going to set the expectations for those products, right? We're going to have an expectation of how long this product should last. And it's going to be a measure of performance and reliability of each individual system. All right, external factors that can impact reliability can be things like overworking a product or system, right? Running it too hard, too long, too hot, whatever that might be. Missing maintenance events or doing maintenance procedures incorrectly will have a negative impact on our reliability of our equipment. So to ensure that reliability in the data center, we want to adopt various techniques to make sure that we have this reliability, right? Maintenance, redundancies, balance between the redundancy and operating efficiency. We want to make sure that we have enough redundancies to operate efficiently, but maybe not over buy on that or under buy on that. We want to make sure we have skilled personnel available, and we want to make sure that we have disaster recovery plans in place and a failure log of maintenance. All right, let's take a look at our reliability risks. So data centers reliability is going to be the key factor, right? Reliability is one of those big feeders into availability in that CIA triad that we're familiar with. Low reliability is going to mean we have more downtime, increased costs for repair and maintenance. We're going to have extra redundancies in the data center if we have low reliability. And if we have high reliability, we're going to ensure we have lower operating costs because we're going to have less downtime. All right, some of the examples of reliability issues can be power loss. So we can have power loss, that means we don't have any power coming into our racks, and that can disrupt service. It can impact our ability to generate revenue, to make money. Can have some unexpected costs. We can be in non-compliance with our service level agreements, our SLAs. It can increase the likelihood that we get sued, give us some negative media attention. I mean, if you think about some failures that maybe AWS or Azure have had, or CrowdStrike, right? These are negative events in the media, and those will have a trickle-down effect onto you as a data center operator. All right, loss of cooling is a significant problem, right? That's going to result in high temperature. And as you get to high temperature, the data center racks are going to overheat. They're going to trip, which means they're going to shut down to prevent fire hazard. As opposed to power, impact of cooling loss doesn't happen immediately, right? It's going to continue to have this build up. And it's a problem. I can tell you from personal experience, a few years ago, my internet service went out was actually out for about 3 days due to the data center that that their ISP's traffic went into had a cooling failure at the data center, and they weren't able to get in and they weren't able to get the cooling system back online for a couple of days. It took them almost 3 days to get the temperature inside the data center down to a level that the equipment was, you could safely operate the equipment again. And believe it or not, that cooling event happened in the wintertime. Um, so interesting. If you ever want to hear what went on, I'd be happy to have a conversation with you about it. All right, reliability and redundancy. So we want to have a certain level of redundancy based on how reliable our equipment is. Um, it's also said even critical systems in the data center are going to have, if they have a redundant system in place, that system may not be able to attain availability levels if components inside of it have problems. All right, and then they talk about availability should be in the range of 5 nines for 99.999%. Um, and I'm sure in other classes I do tend to bring up this 5 nines of operational reliability or availability. Um, if you aren't familiar with the the nines, do a Google search on it, and look, you can find a table that will show you annually at which 99 point whatever nine that is. It will tell you what the amount of downtime per year is, which is really interesting to look at. Because we look at that 99.999% and think, wow, that's a lot. That's really available. Over a course of a year, it's still more than 5 minutes of downtime. So it's interesting to look at those. Why do we want to analyze or do analysis on our reliability risks? So we're going to analyze the risk to support record keeping and resolution record keeping. How quickly did we resolve these problems? It's going to help us to mitigate the risk of data center downtime. It gives, most of all though, I like the third bullet point. It gives us that insight and understanding into the data center's competency level. When I start thinking about these, I start thinking about the fact that if we have good availability data, this is something that is going to be important for our customers. We can actually use it as a marketing tool if we have reasonable a reasonable level of data that we can share with our customers. All right, some different methods of analyzing reliability risk. We can have reliability block diagrams or RBDs, logical tree analysis, hazard analysis, reliability centered maintenance, human error analysis, and maintenance procedure analysis. And the text has more detail on each of these methodologies. But we'll hit a little bit of some of them. So RBD is going to show the end-to-end linking of data center systems. So for example, it might portray or show you the whole power system, whole power circulation from the utility end until the power is actually consumed, right, the load point in the data center. From a connectivity standpoint, it's going to show us the topology of the entire system. It's going to show us where all of the connection points are, and with these RBDs, it can help us foresee some component problems that could be an issue in the operation. Logical tree analysis is going to show us with the tree-like structure where things in the data center are linked together. It's going to show us a tolerable threshold for failure. So, for example, if we look at this little diagram here, we see a system here. If this system fails, right, these three systems depend on it. That's a logical tree analysis. We're looking at where are those fail points going to come in. All right, hazard analysis. We're going to deal with this during site selection to try to build the facility to avoid things like geographic hazard or security hazard or environmental hazard and acoustic exposure, right? What's the impact of the noise? Reliability-centered maintenance programs are going to be effective, but they can be costly. We're going to build these around reliability-centered maintenance, our preventative maintenance, and our failure mode and effective effects analysis, right? Our FMEA. All right, so RCM is going to create failure mode and effects analysis, which is going to give us this decision tree type worksheet. It tells us that you doing this is usually not economical for the data center because it's quite a lot of time, a lot of expert knowledge is required. All right, PM optimization is going to prioritize tasks in our scheduled or preventative maintenance process, which is going to say this maintenance job is more important than that maintenance job. It's that type of thing. The FMEA is going to outline that, hey, if this device fails, then this is what's going to happen. So we're going to go through and look at those relationships, and then we're going to classify critical and non-critical failures to help us focus on what the critical failures might be a little bit more effectively than the non-critical failures. All right, human error still number one in everyone's heart. So human errors happen quite a lot, especially whenever the human has to interact with the equipment. Again, they're talking about poor planning mistakes, lack of skills and knowledge, poor facilities, negligence, poorly written documentations. All of these things can lead to human error, and then eventually human error can lead to a failure. Here are some examples, right? Poor planning, mistakes. Again, I'm not going to go through these. I'm sure most of you have already read this slide before I've gotten this far. So again, human error can lead to issues in the work quality, workload, which can lead to failures. All right, maintenance procedure analysis. We need to do inspect, test, do predictive, preventative, condition-based, corrective maintenance. This was all stuff we covered in the last module, so I'm not going to go into any details on these. And then we're going to take a look at common failure centers, failure places in the data center. So again, the data centers are going to be there to be the underpinnings of our computing systems, and if we have a failure, it's going to have that ripple effect and impact end users down the line. All right, common causes of failures: power failure, network failure, malfunctioning of a device, software collapse, cyber attack, natural calamities, human errors, and the good old other category. All right, so power failures could be caused by battery. So maybe the battery failed in the UPS, and they do. And I will tell you that from personal experience with the UPS, when they're brand new, let's say it has a 1 hour hold time, that it can power everything for an hour. That is the peak. It's going to get worse. It's just like your cell phone, right? It charges up, it'll hold a charge for X number of hours, and then over time you notice you have to recharge it more and more frequently. All right, so what they say with power failure, have an N+1. So however many you need, let's say you need 3 batteries to make sure your UPS runs. N+1 would mean I need 3 plus 1 more battery. Power failures, again, unavailability of redundant components. Again, say power failure as in we lost power from grid. We don't have a backup, right? How many generators do we need? Again, they're saying a minimum of N+1 is redundancy. Circuit breaker overload, which means we've got too much power load. We're drawing too much electricity from a specific circuit. That will cause failure of that circuit. Okay, we need to make sure that when we design these, that we're not going to go over the threshold for that circuit. Network failures. This can have a different set of issues. It can cause we can have device level failures of routers and switches due to age, essentially. We can have a link failure between 2 devices. It could be a result of a configuration change, could be a cable being unplugged. We could have a load balancer that fails, right? Then they've got a list of solutions that go along with those. We could have hardware device issues. So again, we could have a hardware device malfunction due to poor cooling, We could have older devices that are running new equipment requirements. We have chipset power fluctuations. And again, they're telling us to do this, we need to have a backup system ready to put into action um, when that issue arrives. All right, software collapse tells us that data centers are going to have a lot of applications running. Um, and if one of those applications fail, that could cause the whole data center to have a trickle down impact. Here's a list of issues that we could run across. Basically, what they're saying is, hey, know what software you're running, patch it, fix it, make sure everything is running smoothly and correctly. All right, cyber attack. Again, we could have non-authorized attempts to come in and modify our data center systems. Again, they are serious. What do we need to do? Well, we need to have a good security configuration, a good security setup at the data center. All right, natural calamities, right? Earthquake, tornado, heavy hail, thunderstorm, any of these kind of things can cause an issue at the data center. Most of the time, they're going to try to build the data center in a location that has low risk potential to natural disaster, and then basically any risk that we have, we should have some something prepared on how do we deal with it in the event that the natural event happens. All right, human errors, right? How do we minimize human mistakes? We try to automate as much as we can. We use a regulated process. Processes are probably number one, followed up by training, right? Make sure that people know how to follow the process. They're trained to use the equipment that we have, right? We want people to know what your role is. It's always a hard thing, I think, for me, especially as an IT person, is when do I have to kick this process up to the next level? And that can be, if you have clearly defined roles and responsibilities, you should know that, hey, I've reached the maximum of what I can do without calling in level 2 support or something along those lines. And make sure your stuff runs on good processes, have good products, good working conditions. All of that helps. All right, other causes, lots of weirdness can go on. So again, there's a whole range of things, and a lot of it is not necessarily predictable. So we can have other causes of failures, and these are the things that we need to look for and try to build sensors and systems into our day-to-day operations that can try to mitigate that risk or reduce the risk that these other causes can have. And that gets us to the end of Module 12.